Hello, Graham Roberts here. Welcome to this tutorial, which is about the characteristics of an array object. We'll be looking in particular at the ArrayList class, but we'll also speak about ordinary arrays as well. Well, the first thing to say is that you need to import the java.util ArrayList, otherwise you won't be able to use ArrayList. There's a few other things to say as well before we can get really started. You can see that the ArrayList class provides a resizable array, as in contrast with an ordinary array, and it implements the list interface. Methods are provided for you to manipulate the size of the array, and it's used internally to store the list. Now, as you may know, if you use an array list, when you construct it, it's got room already made for you for a number of items, and you can add items and it will extend itself to accommodate it automatically. This is how one could actually implement an array list. This is obviously for just integers. An array list integer list is instantiated using the ArrayList constructor. Here we are constructing integers, and one should note that if you try to put something other than an integer into this list, it will complain at compilation stage and say, oh no, you can't do that. This is one of the many safety features of Java, and although it seems a pain to programmers at first, actually it saves a lot of embarrassment and possible errors creeping into code. If you just use ArrayList on its own, notice the brackets there, that's the constructor identifier. I'll just go back here. So this constructor is used to create an empty list with an initial capacity sufficient to hold 10 elements. Now, here's an example, and I'm actually creating a class called ArrayObjectExample, and then I'm going to instantiate in a variable called myList an ArrayObjectExample object. Then I'm going to ask for that object to show what's contained in it after the constructor's run. That's myList.displayThings, which is my method to do that. And you can see in the display pane beneath what has been output from the program. This is using the OU workspace, which is part of the BlueJ system used by OU students on some courses at the time of making this video, which is 2015. Here is an example using BlueJ. One can see the ArrayObjectExample class that I've created, and the type that I'm going to be storing is itself an object, a thing. So I've created a thing class. Remember that array lists can only hold things that are objects and not primitives like an int. When we run it, we get this. Here's the example the code for thing. The reason it says author Dell is because I'm using a Dell PC at the moment. I'm not called Dell. Okay, so you can pause this and make sure you understand what I'm getting at, perhaps. You can see it's got two fields, or attributes or properties. One is a string, thing name, and the other is an integer, thing age. And one can see that the constructor, the default constructor here, is really doing nothing much at all. And that's the way I wanted it for this tutorial. And I'm not using a non-default constructor at all, because I'm not really teaching polymorphism. I'm just trying to show how an array list may be created and used, and talk about such objects. We have getters and a mutator, that is the setter, set age, and set name. Okay, now this is probably quite difficult to read, but you can see that I actually declare list things, and that could also have been array list, as you saw earlier, but really it's a list, so I've kind of put that there just to remind us it's a list. And when list is used, instead of array list, one will have to import the list library. Okay, so you can see that for yourself as you scan down. The random number is used here, a random number generator, and that may be of interest if you've not used one of those before. Remember, this is the constructor for the class, so the seed for the pseudo-random list is going to be made there for the random numbers. And we actually set the name first, so that it says things and then I, which is the loop counter, and then the age is an integer in the range 0 to 99. That is, 100 is used there, but because we're dealing with, and often are dealing with, indexes that start at 0, this generator produces from 0 to 1 less than the number you place here. And then we add what I've called a record. Now, strictly speaking, perhaps we shouldn't call it a record, but array lists were used and are used to store what have been traditionally called records. This is a method to display what's in the list, and here the calcAverage method is one that loops around, iterates around all of the contents or store that's in the array list, the list, and does a little bit of arithmetic with the age, trying to discover its average. And finally, the main method, where the instantiation takes place and the call to display things occurs. We're going to look a little bit more deeply at this program now. You can see that my actual declaration was ArrayList things, as this is commonly done. And you can see more closely what I've just been talking about. I've created a number of records, or rather I've decided a number of records should be 20, but actually that's really important for when you are using the traditional array rather than this class. I've just put it in there as a mnemonic to show us that normally we need to know when we're dealing with lists how many we're likely to have, but we can relax a little with these kind of collections because they're dynamic, and we have a great convenience that out-of-bound errors are more difficult to achieve. It still can be done, but it's more difficult with the array list than array. As I said earlier, we had the alternative kind of way of declaring where we can use the list on which really ArrayList is an implementation of an interface. But this gets more complicated than it's really worth, and not worth much discussion, just so you know you can see both around. Right, so we can write code to access and use the elements, and here is the example of doing just that. We can process the whole array using ForEach statement, and here's an example of that. You can also use the traditional for loop where you know where the index is. It's just that is like having a dog and barking oneself. Why do that? You could get subscript errors. You're making assumptions. If you're going to process the whole array, then the ForEach loop or iteration is the best. It's only really when you're not going to process the whole loop, but you're going to process a part of the loop, that you'd use the for I equals 0, I less than the size I++ format. Now this is an example, a demonstration of the collection sort, where we've got a list of string, and notice it is a list I'm using there, declaring it as herb list equals new array list. The fact is that the herb list is specific to type string and only that object, and on the right you can see array list with what's known as the diamond operator, horizontal diamond, because it's no longer necessary, I think from version 7 of Java, to repeat the constraint type. Well, we add to herb list chives, then elder, then dill, then angelica, and then basil, and we output what the list is using the helpful system.out utility, which shows us a list without us iterating around it explicitly, sorry, it does it implicitly. Then we sort it alphabetically, and then we sort the herb list using collection sort, and then we see that it's all sorted. So the output from the list is chives, elder, dill, angelica, and basil at the beginning, but then it becomes angelica, basil, chives, dill, and elder. A, B, C, D, E. Well, what if an array, if it's an array, that is the traditional sort of pseudo-primitive array system. Well, here we have much the same setup as before, but it's a classic array, and you can see I've said string, bracket, bracket, herb list, so some dimension, a linear string list, and then I assign values as before, but I have to explicitly state the index, and I could get that wrong. Remember that the array list really is our friend, helping us to avoid simple but classic errors. And when we print out the herb list, we see that it's sorted once we've used the arrays.sort method. So arrays has its own sort method. Well, there must be a problem with collections. What is that? Well, to sort an object with fields, you need to know what the comparables are. What is it that makes one object higher or lower in our esteem than another? If you take, for example, the alphabet, the English alphabet has 26 letters, you might think that A is lower than Z, but it isn't really. They're just letters, a set of letters, and the order is in fact completely arbitrary and meaningless. That's why originally the word spell referred to the magic where you could rearrange the letters of the alphabet into different words, and we called that casting a spell or spelling. Well, I like to believe that story anyway. It's magic. So the alphabet's order is arbitrary. However, in computing we actually give or assign numbers, positions, to those letters. This is so we can sort them. With things example, to use the collection sort, we need to implement the comparable interface with thing as the comparable. If you leave it out, nothing will work in terms of trying to use the collection sort. So here's what we do. In thing, remember that is the object that I'm instantiating, creating and instantiating in order to be stored in the array list. We say implements comparable thing. We are specific about what we are comparing by not only putting implements on the thing we're comparing as an attribute of that, as it were, but we're also saying that comparable can only really compare things. We have to provide a compareTo method. The compareTo method compares two things, and here we're returning a boolean, that is a true or false, according to whether the age of the receiver, this, is greater or less than or equal to a thing dot get thing age, that is the object that we're comparing to the receiver. This will provide an ascending order to the list. If we did it the other way round, it would be a descending order. I spoke about what if it's equal. Well, you need to look up compareTo and see what happens in that situation. So in the array object example, we use a sort method which calls the collections sort method, and we pass to it the collection, that is things, that is the array list. Before the sort, we have this as a list, and the average age turns out to be 917.0 over 20 is 45.85 in this particular case. But note the order of the things by age. Well, there isn't an order by age. It's random, which is why I use the randomizer. Now, after the sort, we actually see the list as being sorted on age in ascending order, and so the sort has been effective on the collection, just as the array sort was for the array variety, the spices. Well, it's time for a few notes. This was never meant to be comprehensive description, a comprehensive description of ArrayList, but rather a commentary on it. looking at its characteristics. You can use the isEmpty method to check an array list, and the size method to get the size. You might find, for example, that the size is equal to 0, in which case it's empty. So you might argue really that the isEmpty method is really not needed, but it exists. You can remove the first object. Remember that duplicates are allowed in an array list. Indeed, it's one of the reasons we use array lists rather than a set, for example. So when you say you want to remove an object, if the object is duplicated, it will only remove the first object. That is, using the remove method. And so we could say things dot remove a particular item or record, or we could say things remove 2, in which case it remove the index 2 value that's stored, record that's stored, and that would be the third one in the array list so far as the index is concerned. You can clear the list, empty it out with the clear method. You can use the set method. It will replace any element a specific index. So for example, here in the code I'm showing, we can replace the second index value, which is of course a record in terms of what I've been describing, or an item. So thing item equals new thing, and then we use the setter, the mutator for item, to give it a no name and then a new age, and then we use the set method of the array list to set the index 1 as the second index to item. Well, let's have a little summary here. Arrays and array lists are indeed very good when you need a loop to manipulate them. This is usually when you've got more than a dozen or so elements to store, and some very clever people in the past have argued that it's only really needed for more than 50 objects, but I think these days, because of convenience, we use an array for anything really several or more. It's very convenient to use ArrayList because it manages its own bounds, more or less. You can sort lists and arrays using built-in methods, but to use a collections sort, you must make sure, if there's anything extraordinary, which there usually is, about what you are trying to compare, you must implement the comparable thing, as I did, and provide a compareTo method